Today's discussion topic is fringe width of wedge-shaped thin film. Before going to these are the outlines of this lecture: introduction and numerical problems. What is a wedge-shaped thin film? A wedge-shaped thin film is one whose surfaces are slightly inclined to each other with a small angle, and that angle is known as wedge angle. For going to calculate the fringe width, fringe width as two surfaces are inclined at a particular small angle, which we considering that is theta, and this is the, suppose say, is the nth fringe, which having thickness t1, and the distance of this fringe from the O is xn. And another one, which is the fringe number is known as, or is n plus 1th fringe, and the distance is n plus 1, and the thickness of that film is t2. Okay, so for this, to calculate the fringe width, we have to understand what is fringe width. The fringe width is the separation between the two successive bright fringe or two successive dark fringe. Okay, means we are considering a two fringes, successive fringes. Suppose we can consider it's a dark fringe, or we can consider it's also a bright fringe. Okay, for dark fringe and bright fringe, we know the condition of bright and dark fringe are 2 mu t is equal to 2n minus 1 lambda by 2. This is for bright fringe. And 2 mu t is equal to 2 mu t is equal to n lambda for dark fringe. Okay. So for fringe width can be considered, suppose say fringe width is the separation between the two successive bright or dark fringe. Okay, this is called fringe width. Suppose say if we are giving the fringe width is denoted by omega. In that case, let us consider xn be the distance of nth dark fringe from the edge O of the film. So tan theta is equal to, we can write it as T1 by xn, or T1 is equal to xn tan theta. For T2, or for xn plus 1 is the distance of n plus 1th dark fringe. Again from O, which is given by 2 mu xn plus 1, sorry, 2 mu xn plus 1 tan theta is equal to n plus 1 lambda. This is the condition for plus 1 lambda. Dark n plus 1th fringe and 2 mu xn tan theta n lambda for nth dark ring. This is the n plus 1th fringe and this is for nth fringe. Now we subtract these two equations, then we get 2 mu xn plus 1 minus xn tan theta is equal to n plus 1 lambda minus n lambda, or we can write it as 2 mu xn plus 1 minus xn tan theta is equal to this one, sorry, this one is cancel out and the term is lambda. The distance between two successive fringes are known as the fringe width, or we are going to present the fringe width with the omega, then we can write it as omega is equal to xn plus 1 minus xn, or this term can be written as 2 mu omega lambda by tan theta, or we can write it as lambda is equal to omega is equal to lambda by 2 mu tan theta. For a small angle, we can write it as lambda upon 2 mu theta. This is the formula for the fringe width. Okay, here we can conclude that the fringe width of the dark or bright fringe is constant as lambda or mu is constant. If the interference fringes are equidistant from one and another, if we increase the theta, means the separation between these two plates, then the fringe width will going to decrease. Okay, because fringe width is inversely proportional to theta. If lambda and mu is constant, if lambda is increased, fringe width will decrease, and lambda is decreased, omega will or fringe width will increase. On the basis of this, we can also solve some numerical. First numerical is the two glass plate, the two glass plates enclose a wedge shaped air film. Touching at one edge and are separated via wire of 0.05 mm diameter at a distance of 15 centimeter from the edge. Calculate the fringe width. Calculate the fringe width. Wavelength of monochromatic light source is 6000 angstrom from a broad source falls normally on the film. We have to calculate the fringe width, means we have to calculate the value of omega. Okay, for this we have a two glass plates enclose a wedge-shaped air film touching at one end and are separated by a wire of 0.05 mm diameter at a distance of 15 centimeter from the edge. As we know, these are the two glass plates and separated by a wire. Suppose this is the wire which having diameter is 0.05 mm. From the distance, means this distance is 15 centimeter. Okay, 15 centimeter, this angle is theta, and we are having a film, air film, means mu is equal to 1. Okay, for theta we can find out mu is equal to 1. This is the 0.05, 15 centimeter. We have to calculate omega. Here lambda is equal to 6000 angstrom. Okay, this is wavelength is 6000 angstrom. For fringe width, we have a formula. Omega means fringe width is equal to lambda by 2 mu theta. So for this question, we have to calculate omega. This is the unknown quantity. For that, we know the lambda, mu, and theta. For lambda, this value is 6000 angstrom, or we can convert it as 6000 angstrom, or we can write it as in centimeter, 6000 into 10 to the power minus 8 centimeter. Okay, so we have to find the lambda. Now mu is 1. For air film, we know mu is equal to 1. For theta, as we know, angle is equal to arc by radius. So theta is equal to arc by radius, or we can write it as arc is 0.005 centimeter. This value is 0.05 mm. For centimeter, 0.005, and the radius is 15 centimeter. The value of theta. Now we have the value of lambda, we have the value of mu, we have the value of theta. Now put these value and find out the fringe width. And omega is equal to 6000 into 10 to the power minus 8 is the value of lambda. 2 into value of mu is 1, and value of theta is 0.005 into 15. Now This comes to 0.09 centimeter. Okay, so this is the answer of that question, and this is the fringe width of that particular data. Now, next numerical. Numerical is light of wavelength 6000 angstrom falls normally on a thin film which is wedge shaped of refractive index 1.4, forming fringes that are 2.0 that are 2.0 mm apart. Find the angle of wedge in seconds. Light of wavelength 6000 angstrom falls normally on a thin wedge-shaped film which having refractive index 1.4, forming fringes that are 2 mm apart. Find the angle of wedge in seconds. Okay, we know the formula. Lambda is equal to omega is equal to lambda by 2 mu theta. We have lambda is equal to 6000 angstrom, or we can write it as 6000 into 10 to the power minus 8 centimeter, and refractive index means mu is equal to 1.4. The fringes are 2 mm apart, means suppose say this fringe is a or nth fringe and this one is n plus 1th fringe. The distance of these two fringes are 2 mm, means this is the fringe width. That means omega is equal to 2 mm. For this, we can convert it as from mm to centimeter, and we can write it as 0.20 centimeter. Omega is 0.20 centimeter, mu is 1.4, lambda is 6000 into 10 to the power minus 8. We have to calculate theta. So we can write it as theta is equal to lambda by 2 mu omega. That means 6000 into 10 to the power minus 8 to mu is 1.4 and omega is 0.20. That comes to 1.1 sorry 10.71 into 10 to the power minus 5 radian. For this radian into, we have to calculate 180 by pi. That comes to degree, which comes to 0.0061 . 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 061, we have a data theta is equal to 6000 into 10 to the power minus 8 upon 2 into 1.4 into 0.20, that comes to 10.71 into 10 to the power minus 5 radian, and convert into 180 degree में 180 by pi, that comes to 0.0061 degree. And for seconds we have to multiply it. Theta is equal to 0.0061 into 60 into 60, that comes to 21.96 second. We have to calculate the angle in seconds. So this is the answer of this question.